Welcome to the deep dive. This is a place where we take that huge, honestly overwhelming stack of reports, benchmarks, forum threads, all the stuff you sent us, and boil it down to the actionable intelligence you actually need.
And today, oh boy, we are diving headfirst into the 2025 AI coding assistant landscape. It's moving incredibly fast. I mean, this isn't just autocomplete anymore, not by a long shot.
No kidding. We're talking systems that can debug code, write tests, even refactor, huge complex code bases almost on their own.
It's rocketed past that simple stuff.
Exactly. And you, our listener, our learner, you're trying to navigate this market, and it's just dizzying, right? You've got the big players, the generalists like Google and Microsoft fighting for your attention. But then you also have all these hyper-focused niche tools popping up, tools promising to solve really specific pain points in your workflow.
The noise level is just incredible. It's hard to figure out what's real, what's hype.
Totally. So you need a clear map. You need to know where to invest your time, your resources, which tools are actually worth looking at.
And that's exactly our mission for this deep dive. We're going to distill the really critical insights from all those sources you provided.
Okay, so how are we structuring this?
We're looking at three major forces shaping the market right now. First, we need to understand the new baseline. Like, what are the minimum expectations for a modern AI coding tool? What must it be able to do?
Okay, but table stakes.
Right. Second, the big head-to-head. We'll compare the two main generalist ecosystems, Gemini versus GitHub Copilot. Put them side by side.
The heavyweights, got it.
And third, we'll explore the rise of the specialized tools and these new agentic systems, the tools that are starting to automate entire phases of development.
All right, sounds like a plan. Let's start with that new baseline, the new normal.
Okay, so the state of AI and coding now, it's just fundamentally different than it was even, say, 2 years ago. We're really past not just autocomplete anymore. That phrase sums it up.
Right.
The main goal has shifted. It's not just about helping you type faster. It's about genuinely reducing your cognitive load.
Okay, explain that. Reducing cognitive load.
It means the AI handles more of the mental grunt work. Context switching, remembering boilerplate syntax, figuring out dependencies. It frees up the human developer, you, to focus on the harder problems, the architectural stuff, the real complexity.
So it's like having a really, really capable pair programmer next to you.
Exactly. A partner, not just a suggestion box. And the capabilities developers expect now are, well, seriously advanced. Forget simple variable suggestions.
What are we talking about?
We're looking at context-aware code generation. The AI needs to understand dependencies across multiple files, maybe even the whole repository.
Okay, so it knows the whole project.
Ideally, yes.
Yeah.
And natural language to code conversion. You should be able to describe a feature in plain English, just, type it out.
And it starts building it?
It starts scaffolding it, yeah.
Yeah.
Generating the basic structure, the functions, the imports, plus automated documentation, writing doc strings, summarizing code blocks.
That alone sounds amazing.
Oh, it's huge. And intelligent refactoring suggestions. Not just finding bugs, but suggesting better ways to structure the code. And inline explanations explaining complex bits of code you didn't write.
Okay, but you mentioned something earlier. Codebase-Wide Pattern Recognition. That sounds powerful. Let's pause on that. What does that mean in practice?
It means the AI isn't just looking at the file you have open right now in isolation. It's read the entire project history.
The whole thing.
Yeah, the naming conventions your team uses, the testing frameworks, the architectural style, the dependencies. It's absorbed all of it.
So if I start writing a new function,
the AI won't just suggest syntactically correct code. It'll suggest code that fits your team's specific way of doing things. It follows the existing patterns, the established standards.
that's the difference maker, isn't it? Understanding the projects, like institutional knowledge.
Precisely. That's what separates the truly modern systems from the older, more basic tools. It understands the context of the project, not just the line of code.
Okay, that sounds incredible. But who's really benefiting most here? Is this mainly a tool for senior developers to go faster, or does it help, say, junior devs just as much?
It's actually a really broad spectrum, which is why these tools are getting adopted so widely. On one end, yeah, experienced programmers are seeing huge velocity gains.
Automating the boring stuff.
Exactly. The repetitive tasks, the boilerplate code that used to eat up, 20–30% of their day sometimes, they're using it for rapid prototyping, getting ideas working much faster.
Okay, makes sense. And for the newer developers, the ones still learning.
For them, these tools are becoming, honestly, indispensable learning companions. Imagine being able to instantly ask the AI, hey, explain this complex library function to me, or break down this recursive logic, or even summarize what this pull request is trying to do in plain English.
Like having a tutor available 227.
Kind of, yeah. It lowers the barrier to entry quite a bit, and it speeds up learning because you get immediate personalized feedback. It's almost like instant mentorship right there in your editor.
Okay, so it benefits both ends of the experience spectrum. Now, the tricky part, with all these tools flooding the market, how are developers actually choosing? Your sources pulled together 10 key factors, right? Let's dig into the most crucial ones, maybe the top 6, because that really sets the stage for comparing things like Gemini and Copilot later.
Absolutely. Let's nail these down. First, and probably the most fundamental, is syntax and language complexity support. The AI has to give you real-time, accurate suggestions, especially if you're working in, say, a less common language or using tricky functional programming stuff.
If the suggestions are slow or just wrong, you'll just turn it off.
Instantly. Forget it. Second, it's moving beyond just spotting errors to actual problem solving. We call it debugging and error resolution.
So not just highlighting a typo.
No, much more. It needs to look at a runtime error, a stack trace, and suggest actionable fixes, like change this line of code to this, and ideally tell you why that fixes the problem.
Giving the reasoning. Okay, that's third.
Third is about the quality of the code generated, code efficiency and optimization. The AI shouldn't just write code that works. It should suggest better ways.
Like refactoring.
Exactly.
Yeah.
Maybe converting a slow, clunky loop into a slick list comprehension in Python, or spotting where you could use async processing in JavaScript to speed things up. It's about promoting high-quality, efficient code.
Number 4 must be about practicality, right? Integration.
You got it. Seamless integration and compatibility. Look, a tool could have the smartest AI in the world, but if it doesn't plug smoothly into your existing workflow, your VS Code, your JetBrains IDE, your terminal, your CI/CD pipeline, it's basically useless.
Nobody wants another clunky tool or window to switch to.
Absolutely not. If it forces you to change how you work or constantly switch contexts, adoption just dies right there.
Okay, 5th. This one sounds important for bigger projects.
Hugely important, especially in enterprise settings or when dealing with older legacy code bases. Scalability and maintainability. This connects back to that code-base-wide understanding.
How so?
Can the tool analyze a massive existing project, maybe identify areas that are overly complex or full of technical debt, and then recommend long-term strategies for refactoring? Strategies that will make the code base easier to maintain and scale in the future. It's about helping developers think 6 months, a year down the line.
Planning ahead. Makes sense. And finally, number 6. This has to be security, right?
Bingo. The ultimate hurdle for production code. Security and vulnerability mitigation. The best tools now aren't just writing code. They're actively trying to make it secure as you write it.
How? Like, what are they catching?
They're flagging dangerous patterns, things like finding hard-coded API keys or passwords in the code, warning about potential SQL injection risks, or spotting the unsafe use of functions like evil that can execute arbitrary code.
And it finds these before the code gets checked in.
Ideally, yes, right there in your editor before it even leaves your local machine. That's a massive first line of defense in the whole software development lifecycle, the SDLC.
Okay, so that's the high bar these tools need to clear. Now, let's get into the main event you mentioned. The direct comparison, the clash of the titans. We've got GitHub Copilot on one side.
Yep, built from the ground up for coding, backed by Microsoft and OpenAI. Massive resources.
And on the other side, Google's Gemini.
Yeah.
More of a multimodal generalist, but Google's been pushing hard to make it a serious contender for developers too.
It really is the battle of the ecosystems, isn't it? And fundamentally different AI philosophies behind them. Copilot is laser-focused on structured coding productivity. Gemini aims broader research, reasoning across different types of information.
Let's look under the hood then. What are the core engines powering these two?
Okay, the power source dictates a lot. Copilot primarily uses OpenAI's models. For the free tier, it's often GPT-4 turbofast, pretty capable.
And the paid version.
The paid tiers, Copilot Pro, or what they sometimes call Smart Mode, leverage the more powerful GPT-4 and potentially GPT-5 down the line. The focus there is really optimize speed and accuracy specifically for structured coding tasks, getting you the right code snippet fast.
Okay. And Gemini, different approach.
Totally different family. It uses the Gemini 2.5 models. There's Flash, which is built for speed, and Pro, which is better for more complex reasoning. But the big technical differentiator for Gemini is multimodality.
Explain that. What does multimodality really mean here?
It means the model wasn't just trained on text and code and then sort of bolted on to handle images or audio later. Gemini was designed from the very beginning to natively understand and reason across different types of data simultaneously: text, images, code, spreadsheets, even audio and video inputs.
So it can look at, say, a design mock-up image
Yeah.
and generate HTML for it, or analyze a spreadsheet of bug reports alongside the code.
Exactly. That native multimodality is why it often feels stronger as a general research or content creation tool. It can connect insights across different formats in a way that text-focused models might struggle with. And that capability definitely extends into technical tasks, too.
Interesting. But you said there was one really big technical difference, especially for people working on large, complex projects.
Ah, yes, the context window. This is absolutely critical.
Remind us what that is again.
It's basically the AI's short-term memory. How much information it can hold and actively consider during a single conversation or when analyzing files you give it.
And how do they compare?
This is where Gemini currently has a massive, massive advantage. Your sources consistently show Gemini 2.5 Flash and Pro supporting up to 1 million tokens.
1 million tokens. What does that translate to in practical terms?
It's huge. Think hundreds of code files or a really long, dense technical specification document or maybe a dozen research papers. It can analyze all of that at the same time without forgetting what was at the beginning by the time it gets to the end.
Wow.
That capacity is genuinely game-changing for tasks that need deep context understanding or analysis across many, many files. Think refactoring a large module or understanding a complex legacy system.
I didn't realize the difference was that dramatic. So you could feed it an entire microservice code base or a big API spec plus your current files, and it can reason across all of it.
Pretty much, yeah. Now, compare that to Copilot.
Okay, how does Copilot stack up?
Even the advanced paid tiers of Copilot generally operate with a context window around 128,000 tokens. Now, 128K is not small. It's plenty for most single-file tasks or typical coding conversations.
But it's dwarfed by 1 million.
Absolutely dwarfed. If your task involves analyzing, say, an entire academic paper for insights relevant to your code, or understanding the interactions across dozens of files in a distributed system, Gemini's larger window gives it a clear quantitative edge on sheer memory capacity.
Okay, context window. Big win for Gemini. What about integration? The ecosystem play. This must be where platform loyalty kicks in.
Oh, absolutely. This is the commercial reality, right? Copilot is Microsoft. It's deeply woven into the entire Microsoft 365 suite. You find it in Word, Excel, Outlook, Teams, PowerPoint.
And for developers,
it lives and breathes inside VS Code and the JetBrains IDEs. If you're heavily invested in the Microsoft ecosystem, Copilot feels like a natural extension.
And Gemini naturally is the Google champion.
Of course. It excels within Google Workspace Docs, Sheets, Gmail, Calendar, Drive. It integrates seamlessly there. Plus, it has that neat live voice mode that can connect to your Google Maps and Calendar for hands-free planning and scheduling while you're, commuting or whatever.
So if your life and work run on Google services, Gemini slots right in as that all-around assistant.
Exactly. It comes down to where you spend most of your digital time.
All right, let's shift gears to actual coding performance. When you put them head-to-head with the same prompts, the same coding challenges, what did the tests reveal? Was there a clear winner?
It was actually more nuanced than that. The overall verdict from the sources was a split decision. Both are incredibly capable, but they seem to serve fundamentally different developer needs or preferences.
How so?
Gemini consistently came across as the helpful teacher. Its responses prioritize clarity, detailed explanations, safety warnings, and providing a lot of context.
Okay, the teacher and Copilot.
Copilot was the efficient coding partner. It prioritized raw speed, minimalism in its output, and just getting a working code snippet into your IDE as quickly as possible. Less hand-holding, more direct action.
Can you give an example, like for a simple task?
Sure. Take something basic, like generating a simple Hello World web app using Flask in Python, or writing a function to reverse a string. Copilot spat out clean, minimal, production-ready code almost instantly.
No extra fluff.
Exactly. Very few comments. Just the code. For an experienced developer who knows exactly what they want and just needs the boilerplate done fast, Copilot often won on pure speed and usability, less visual clutter in the editor.
Okay, speed for Copilot. Did that hold up for more complex things like optimization?
Generally, yes. When they were prompted to optimize a basic, inefficient bubble sort algorithm, Copilot quickly provided the standard efficient version using the swapped flag to exit early. And again, it did so with very minimal comments, just focus on the optimization logic itself. Fast and surgical.
Okay, so Copilot is fast and concise. What about Gemini on those same tasks? You called it the teacher. Was it slower? More verbose?
Yes, pretty much universally. For those same simple tasks, the Flask app, the string reversal Gemini's responses were significantly longer.
Longer how?
They included detailed inline comments explaining what the code was doing. They often added extra explanations about why certain choices were made. And importantly, they frequently included safety notes.
Safety notes? Like what?
And like for the Flask app, Gemini explicitly warned about the security risk of using hosts 0.0.0 in a production environment, explaining it makes the server publicly accessible. For the string reversal, it might give a little tutorial on how Python slicing and step values actually work.
So more educational, but potentially more noise if you already know that stuff.
That's the trade-off, exactly. That verbosity, that teacher approach can sometimes feel counterproductive. If you're a senior dev just trying to move fast, it can clutter the screen.
But is there a scenario where that extra detail, that teaching approach from Gemini, actually leads to better code?
Yeah.
Maybe for more complex or critical tasks?
Yes, absolutely. And the sources argue this is where Gemini's thoroughness really shines. Consider a slightly trickier task, translating a Python function, let's say a factorial function, into Java.
Okay, how do they differ there?
This was a great example. Gemini didn't just do a literal line-by-line translation. It applied good programming practices. It correctly suggested using the long data type in Java for the return value.
Why is that important?
Because factorials grow incredibly quickly. Using a standard int would lead to integer overflow errors for relatively small inputs. Gemini anticipated that potential bug.
Proactive error prevention. Nice.
And it also added logic to handle invalid inputs, like throwing an illegal argument exception if you tried to calculate the factorial of a negative number. It added defensive programming.
And Copilot.
Copilot, while likely faster, tended to give the more direct minimal Java translation, which worked, but it often meant the developer would have to manually add those checks for overflow and negative inputs themselves. Gemini built in that robustness from the start.
So, a potential win for Gemini in terms of production hygiene and catching edge cases.
Yeah.
What about something like writing tests? That feels like another area where detail matters.
Exactly. The unit testing prompt was another standout teacher moment for Gemini. They were asked to write a just unit test for a simple JavaScript utility function.
How did Copilot handle it?
Copilot gave the clean functional test cases, good tests, ready to run, assuming the developer already had just set up and knew how to run the tests.
Okay, and Gemini?
Gemini went way beyond that. It provided a full-on mini tutorial.
Okay.
It included instructions on how to install Jest using NPM or Yarn. It suggested a standard file structure, where to put your test file relative to your source code. It generated comprehensive test cases covering not just typical inputs, but also tricky edge cases like nan, infinity, null, undefined, empty inputs.
Really thinking about robustness.
Absolutely. And then it even provided the exact command line instructions for how to run the tests and how to interpret the pass-fail output.
Yeah.
For someone new to Jest, or even just new to testing that specific function, that level of detail is incredibly valuable learning support.
Okay, that's a clear difference in philosophy. One more coding example. Security analysis. You mentioned the Gemini CLI.
Yes, the command line interface agent for Gemini showed real value here. When asked to analyze a sample Node.js Express application file for security issues, it did a pretty impressive job.
What did it find?
It flagged several critical concerns very quickly. First, it noted an unused dependency, the FSS module for file system access, was imported but never used. That increases the potential attack surface unnecessarily.
Good catch. What else?
It found a hard-coded secret, like an internal token, directly in the configuration object within the code, a huge security no-no. And maybe most critically, it identified the dangerous use of the evil function, pointing out the severe risk of code injection vulnerabilities if user input ever reached that function.
And it's surfaced all that right in the terminal.
Right there. Turning static analysis findings into actionable security warnings, ideally before that vulnerable code ever gets committed or deployed. That's a concrete win.
Okay, so summing up the coding part. Gemini seems to win on thoroughness, guidance, safety, and teaching, maybe better for robust production code and learning. Copilot wins on raw speed, and minimalism potentially better for experienced devs focused purely on velocity.
That captures the core difference pretty well based on these tests.
Now, since Gemini is positioned as this broader, multimodal AI, and Copilot is also expanding beyond just code, We need to look at how they handle more generalist tasks, too. Things like, I don't know, creative writing, summarizing documents,
Yeah.
tasks that developers actually do sometimes, right? Writing documentation, analyzing reports.
Absolutely. It's part of the modern developer workflow. Let's start with creative writing. There was a specific prompt requiring a short sci-fi story.
Okay.
It had to include a lonely explorer, a sentient AI companion named Echo, and importantly, a specific derelict spaceship named the Wanderer.
Details matter. Who did better?
Gemini nailed it. It hit every single detail from the prompt, including explicitly naming the ship the Wanderer. And the story itself was well-structured, engaging. It felt pretty polished, almost like something ready for publication.
In Copilot?
Copilot's story had a really strong, evocative, almost poetic tone. Many found it quite compelling from a purely stylistic perspective. However,
That's something.
it missed the key technical requirement. It didn't name the ship the Wanderer. It described a derelict ship, but failed on that specific instruction. So a technical win for Gemini on following the prompt precisely, even if Copilot maybe had a more artistic flair. Sometimes you trade compliance for tone, I guess.
Interesting trade-off. Okay.
Wow.
What about analyzing big documents, like reading a PDF report and summarizing it?
Yeah, this was a good test. They were both asked to summarize a lengthy, complex PDF, the U.S. Surgeon General's report on social media and adolescent mental health.
The meaty document, how do they do?
Both did a decent job extracting the main factual findings. Gemini's summary was very direct, very data-focused. It concentrated heavily on the report structure, the methodology, the core statistical findings. Very factual.
And Copilot?
Copilot took a slightly different approach. Its summary felt more editorialized, more polished and structured for readability. It used clear headings like key finding, methods, conclusion, implications.
Making it easier to digest.
Exactly. It framed the information with better clarity and flow. It felt more like a ready-to-use summary you could drop into an article or presentation. So while both got the facts, Copilot seemed better optimized for synthesizing dense information into professional, consumable content.
Okay, so maybe a slight edge to Copilot for summarization clarity. Finally, what about image generation? That plays to Gemini's multimodality strength, right?
It certainly should. The test was to create a specific stock photo, a female bookstore owner, cozy lighting, wooden shelves, and crucially, a small dog present in the scene.
Who won?
Gemini won this one pretty clearly. It generated the image that most accurately included all the requested elements. The composition was good, the quality was high, it looked like a usable stock photo you could actually deploy. Copilot and other models struggled more with getting all the specific elements correct in a single, coherent image.
All right, so Gemini's multimodal roots show through there. Before we move off these two, let's do a quick reality check on pricing. Because ultimately, for individuals, for smaller teams, cost is a huge factor.
Absolutely. The good news is both offer pretty capable free tiers to get started, but for the advanced features we've been discussing, the bigger context windows, the more powerful models you generally have to pay.
And how do the paid tiers compare? Are they similar?
They're actually in rough parity price-wise. Copilot's individual plan starts around $10 a month, and the business tier with more features is about $19 per user per month.
In Gemini?
Gemini Advanced, which gives you access to the more powerful models like Gemini Pro 2.5, starts at $19.99 a month. That's often bundled with other Google One premium services like extra storage. So yeah, for the premium experience, you're looking at around $20 a month for either one.
Okay, so we've got the big picture on the generalists, Gemini and Copilot. Powerful, broad, but maybe not perfect for every single need. Now let's shift focus, like you said, to the specialized tools.
Exactly. The assistants that aren't trying to be everything to everyone, they're built to tackle one specific, often painful part of the development process really, really well.
Like security or privacy, or maybe focusing deeply on just one programming language.
Precisely. This is where a lot of the really interesting innovation in workflow efficiency seems to be happening right now. These tools are like surgical strikes against specific developer bottlenecks.
Okay, where do we start? Security seems like a big one.
Definitely. Let's talk about Quoto first. This one stands out because it's not just a code generator. It aims for comprehensive coverage across the entire software development lifecycle, the SDLC.
The whole life cycle. How does it do that?
It's fundamentally built as a multi-agent system. That means it has different AI agents, each purpose-built for a specific task.
Like different specialists on a team.
Kind of, yeah. There's a gen agent for generating code and scaffolding tests. There's a cover agent specifically focused on improving code and test coverage metrics. And maybe most importantly, there's a merge agent designed for analyzing pull requests.
So quality checks are built into the flow, not just an afterthought.
Exactly. The Quoto merge PR agent is particularly interesting according to your sources. When someone submits a pull request, this agent automatically jumps in.
What does it do?
It does several things. It provides an estimate of the effort involved in the changes. It tries to identify the main focus or purpose of the PR. And critically, it performs automated security vulnerability scanning on the proposed changes.
Wow. All automated in the review step.
Yeah, and it goes further. It doesn't just read the code. It analyzes the complexity being introduced and even estimates the potential future maintenance burden of that code before it gets merged.
That's pretty advanced. Okay, who else is big in the security space?
Another major player is Deepcode AI, which is now part of SNCC, a well-known security company. Deepcode is laser-focused on security from the start.
What's their approach?
They use a really interesting hybrid model. They combine symbolic AI with generative AI.
Okay, break that down. Symbolic versus generative.
So generative AI, like the models in Copilot or Gemini, is great at understanding natural language, generating new code, and suggesting fixes in a human-readable way.
Right.
Symbolic AI, on the other hand, is more like traditional computer science logic. It excels at formal verification, deep logical analysis of code structure. It's really good at finding non-obvious flaws, complex injection risks, things that rely on understanding the precise logical flow of the existing code.
So Deepcode uses both, the pattern matching of generative AI and the deep logic of symbolic AI.
Exactly, and they train these models specifically on the huge amount of security vulnerability data that SNCC collects. This allows Deepcode to offer continuous security monitoring right inside your IDE, flagging potential issues as you type.
Any downsides?
The main constraint noted is that its language compatibility might be a bit more restricted than the big generalist tools. It's highly specialized.
Makes sense. Anyone else focused on quality and review?
Yes, Codiga. This tool also puts a heavy emphasis on automating code reviews and static analysis alongside its code generation features. It's really strong on detecting potential vulnerabilities, code quality issues like excessive complexity or duplication, and security flaws.
So instant feedback on quality.
Instant contextual feedback, yeah. The potential drawback mentioned in your sources is that because it's quite sophisticated and enforces strict quality standards, it can sometimes have a steeper learning curve for developers who aren't already familiar with those kinds of formalized code quality metrics.
Okay, so we've covered tools focusing on security and quality. What about another huge concern many developers have with cloud-based AI privacy and data leakage, and also keeping context over time?
Huge issues. And there are specialized tools tackling exactly that. Let's start with one called Pieces for Developers. Your sources describe it as a fascinating and perhaps underrated workflow assistant.
Workflow assistant. How's it different?
Its standout feature is something called long-term memory, LTM. Pieces tries to capture context, not just from your IDE, but from everything you do, your browser activity, Slack messages, other tools. It builds a persistent knowledge base about your work.
So it remembers what you were doing yesterday or last week. Minimizes context switching.
That's the goal. But the killer feature for privacy-conscious folks is the Pieces OS. This allows you to run powerful large language models, LLMs, locally on your own machine.
Run the AI locally, not in the cloud.
Exactly. All the code analysis, the suggestion generation, processing of potentially proprietary information, it all happens on your device. Nothing gets sent to external servers.
That's the ultimate privacy guarantee then, especially for companies working with sensitive intellectual property or under strict regulations.
Absolutely. Zero data leakage, total control.
But wait, running a big LLM locally, doesn't that require a beast of a machine? Can the average developer's laptop handle that without grinding to a halt?
That is the primary trade-off. Modern hardware is getting better, but yes, running a truly capable LLM locally is still very resource-intensive. It needs significant RAM and processing power.
So what's the reality?
Your sources caution that developers using older machines or machines with limited RAM might definitely experience slowdowns, especially if they're also running other demanding things like virtual machines or lots of Docker containers. It's a clear choice. Absolute privacy and control versus potential performance hits and resource consumption.
Okay, so Pieces offers local control at a potential performance cost. Who else addresses privacy, maybe with a different approach?
There's Tabnine. Tabnine has been around for a while and is known for its deep learning models that adapt really well to your specific coding style over time. It learns how you write code.
Does it run locally?
It often relies on the cloud for its most powerful models, but its key differentiator has always been a very strong commitment to data privacy. They have clear policies about ensuring your code snippets aren't retained or used to train models for other organizations unless you explicitly opt into team-specific model training within your company. They focus on transparent privacy controls.
So cloud-based, but with strong privacy guarantees. What about the open source crowd? People who want total control and transparency.
For them, there's Qwen3 Coder, which comes from the Unsloth project. This is a powerful LLM specifically fine-tuned for coding tasks, and it's released under an open source license.
Meaning you can download it, modify it, run it wherever you want.
Exactly. It offers potentially top-tier performance and complete customizability for users who really want to get under the hood and control every aspect of the AI.
Sounds great, but I'm guessing there's a catch. It's not just plug and play like Copilot.
Oh, far from it. Being open source and a base model means it requires significant technical effort. You need to handle the setup, the configuration, managing dependencies yourself.
And it doesn't just pop up in your IDE.
No, it's just the core model. To actually use it seamlessly within VS Code or another IDE, you need to integrate it using other tools, like wrapper applications such as Cursor or Aider. So it's really the choice for highly sophisticated users who are willing to invest significant setup time in exchange for that absolute control and customization potential.
All right, we've seen security specialists, privacy specialists. What about tools that focus on just being incredibly deeply integrated into the IDE itself, maybe even creating an AI-first coding environment?
Yes, that's another major trend. Tools that aren't just plugins, but fundamentally rethink the IDE experience around AI. We're talking about tools like Cursor and Windsurf.
Cursor and Windsurf, what's their deal?
Both are actually forks of VS Code, the popular editor. They take the VS Code base that many developers love and then build enhanced AI capabilities right into the core experience. Their main focus is often on solving that tricky multi-file context problem really well.
Going beyond just looking at the current file.
Exactly. They want to understand the whole project deeply. Windsurf, for example, which comes from the company Codium, talks about achieving entire codebase awareness using something they call cascade technology.
Cascade technology. How is that different from just having a large context window like Gemini?
It seems to be more about how the context is managed and prioritized, not just the raw size. Cascade technology apparently intelligently analyzes file dependencies and relationships. So when you're working on a specific function, it focuses its AI attention not just on the current file, but on the most relevant related files, the models, controllers, configuration files, utility functions that are needed to understand the full context of that piece of code. It aims for deeper contextual awareness than the standard mechanisms like the language server protocol, LSP, typically provide.
So smarter context management. And Cursor, what's its angle?
Cursor aims to feel almost like telepathy for developers who are already heavy VS Code users. It offers very intelligent code completion, sophisticated refactoring tools that understand the project structure, and an inline AI chat feature that is deeply aware of your repository's code and even its history. It's about making the AI feel like a natural, seamless extension of the VS Code environment they already know.
Okay, those are AI-first IDEs built on VS Code. What about developers who are already using other established IDEs, like from JetBrains?
For them, the JetBrains AI assistant is a major offering. JetBrains makes popular IDEs like IntelliJ IDEA for Java, PyCharm for Python, ReSharper for .NET, and so on. Their AI assistant integrates natively right inside these existing, very robust IDEs.
So less disruption to their existing workflow.
Precisely. And it's often praised for providing context-aware suggestions with what users call JetBrains-level precision. It leverages the deep static code analysis capabilities that JetBrains IDEs have always been known for, making the AI suggestions highly relevant to the specific project and language context.
You mentioned PyCharm specifically. That brings up language specialization. Are there AI tools best suited for just one language, like Python?
Absolutely. PyCharm, the JetBrains IDE for Python, is often considered the gold standard if your primary focus is Python development. Because the AI is built right into that highly specialized Python IDE, it has a fundamental deep understanding of Python conventions, libraries, and best practices.
So the best AI for Python code.
Many Python developers would argue yes, particularly for generating idiomatic, high-quality Python code. The caveat mentioned in your sources is that sometimes for very complex or niche architectural problems that go beyond typical Python patterns, its suggestions might become a bit more generic compared to the large generalist models.
Makes sense. Okay, one more specialized tool, particularly relevant for cloud developers. Amazon Q Developer.
Yes, Amazon Q is a powerful player, but it's very clearly optimized for developers working within the Amazon Web Services AWS ecosystem.
So best if you're building on AWS. What are its key features?
A major one is its security-first design, specifically how it integrates with AWS Identity and Access Management, or IAM.
IAM roles. Why is that so critical for an AI assistant in an enterprise setting?
Think about a typical large company using AWS. A developer usually doesn't have permission to access everything. They might have read-only access to certain production databases, write access only to their specific development environment, and no access at all to sensitive financial data buckets in S3.
Right. Strict permissions are crucial.
Amazon Q is designed to respect those existing IAM roles. The AI assistant operates with the same permissions as the human developer using it. It can't access resources the developer isn't allowed to access. That's a huge deal for security and compliance in enterprise AWS shops.
That is a critical feature. What else can it do?
It also has strong agentic capabilities, which we'll talk more about next. It can actually execute commands like bash commands in the terminal and interact directly with AWS APIs. So you could ask it to, say, troubleshoot a deployment issue by checking CloudWatch logs, or even help provision resources by making API calls, things that go beyond just writing code.
Powerful, but sounds like it might be less useful if you're not heavily invested in AWS.
That's the feedback from the sources, yes. Its outputs and capabilities can sometimes feel underwhelming or less relevant when you're working on tasks outside of a direct AWS context. It knows AWS inside out, but might be less helpful for, say, a pure front-end React project with no AWS dependencies.
Okay, we've covered the generalists and the specialists, but you mentioned something intriguing, agentic capabilities, agent mode. This sounds like the next big leap, moving beyond just assistance to something more autonomous.
Exactly. This is where things get really interesting and perhaps a bit sci-fi. We're moving towards systems that don't just respond to a single prompt, but can take a high-level goal and execute a whole series of steps independently to achieve it, with much less human hand-holding. That's agent mode.
So, not just completing a line of code, but handling a whole task.
Precisely. Think about planning the steps, writing code across multiple files, maybe running terminal commands to install dependencies or run tests, and then iterating based on the results, all driven by that initial high-level goal you gave it.
We saw a glimpse of this with Amazon Q, right? You mentioned it could create a whole microservice.
Perfect example. You could give Amazon Q a single prompt like, create a secure GitHub webhook listener microservice in Python using Flask. And the agentic part kicks in.
What does it do then?
It doesn't just generate one file. It figures out all the necessary components. It generates the main Python file, main.py, with the Flask app, including crucial security features like signature verification for the webhook. It creates a sample environment file, .env, for configuration secrets. It generates a requirements.txt file listing all the needed Python libraries. It does the whole setup autonomously from that one request.
That's a significant chunk of work done automatically. Are there other examples of these agentic systems?
Yes, another interesting one highlighted is Clefline. It bills itself as a local-first coding agent. It uses a very structured approach called a plan and act workflow.
Plan and act. How does that work, and why is it different from just letting the AI run wild?
The plan and act model is designed for developers who want automation but also need visibility and control. First, Clan takes your goal and generates a detailed step-by-step plan in human-readable language, like Step 1. Create a new file named testdatabase.py. Step 2. Add boilerplate test setup code to database-connector.py. Step 3. Modify the existing runtest.ish script to include the new file.
So you see the plan first.
Exactly. You review the plan. Then, critically, it requires your explicit approval before it starts executing those steps and actually modifying files or running commands. This gives you a chance to catch potential issues or misunderstandings before the AI makes changes.
Accountability and trust built in.
Right. And Clean is also designed to create snapshot checkpoints along the way. So if one of the steps introduces a bug or doesn't work as expected, you can easily roll back to the previous stable state. It's about making the automation transparent and safe.
Okay, that sounds useful for individual developers.
Right.
What about really large, complex, maybe enterprise-level development? Are there agentic frameworks for that scale?
Yes, your sources point to MetaGPT as a prime example here. MetaGPT isn't just a single agent, it's a sophisticated multi-agent framework. It tries to mimic human software development team structures and processes.
Mimic human teams.
It uses formal standardized operating procedures, SOPs. It assigns different AI agents specific roles, just like a real team, maybe a product manager agent to define requirements, an architect agent to design the system, an engineer agent to write the code, a QA agent to write tests.
Okay. Different agents with different jobs. Why the SOPs? What's the benefit of that formality?
The SOPs are crucial for reliable communication between the AI agents. They define structured protocols and data formats for how information is passed. For instance, the architect agent's output might be a strictly defined JSON schema detailing the components and APIs. The engineer agent is programmed to understand and parse that specific schema reliably.
Ah, so it prevents misinterpretations between the AIs.
Exactly. It helps avoid the hallucination drift or cascading errors you can get when AI agents have unstructured, natural language conversations amongst themselves. The SOPs ensure information flows correctly and predictably through the different stages of the simulated development process.
That sounds like a serious attempt to automate large chunks of the workflow. And speaking of automating painful parts, code reviews.
Wow.
That's notoriously time-consuming. Is AI tackling that in an agentic way too?
Oh, absolutely. AI is rapidly becoming standard practice for automating and standardizing code reviews. It's moving from a manual bottleneck to a much more efficient, automated quality gate.
Which tools are leading here?
CodeRabbit is one frequently mentioned. It provides contextual, often line-by-line feedback on pull requests. It can generate detailed summaries of what the PR does, and critically, it's designed to learn from how developers interact with its suggestions.
It gets smarter over time, adapts to the team.
That's the idea. It learns the team's specific coding standards and preferences, refining its suggestions to align better. It helps enforce consistency and best practices automatically.
And you mentioned Quoto earlier had a merge agent.
Right, we circle back to CodeMerge. Its specific strength is that deep, automated PR analysis. It doesn't just suggest fixes. It can offer concrete, committable code improvements. Developers can interact with it using simple slash commands in their PR interface, like review to trigger a full analysis or describe to get a summary. It ensures every PR gets that consistent check for quality, security, complexity, and even estimated maintenance impact before it gets merged. Hashtag outro, synthesis, and final thought.
Wow. Okay, we have covered a ton of ground, from the basic functions to the Gemini Copilot battle to all these specialized and now agentic tools. So after this really deep dive, where does this leave you, the listener, navigating this landscape in 2025?
It's a lot to take in, for sure, but I think the synthesis really boils down to two main strategic paths you can consider based on everything we've discussed from your sources.
Okay, path number one.
Path one is sticking with the generalist, multimodal tools, which is primarily the choice between Gemini and Copilot. The decision there really hinges on your primary environment and your main goals.
So choose Gemini if.
Choose Gemini if you need that massive 1 million token context window for deep analysis of large code bases or documents, if you value its teaching ability, the detailed explanations, the safety checks, and the robust handling of edge cases, if you need strong performance on non-code tasks like research, content generation, or image analysis, and, of course, if you're deeply integrated into the Google Workspace ecosystem.
Okay. And choose Copilot if.
Choose Copilot if your absolute top priority is speed and minimalist code completion. If you want lightning-fast suggestions right in your IDE with minimal fuss. If you're an experienced developer who values velocity above detailed explanations. And naturally, if you live primarily within the Microsoft 365 universe or are a die-hard VS Code or JetBrains user who wants seamless integration there.
Got it. Generalist path, Gemini for depth teaching Google, Copilot for speed minimalism Microsoft. What's path two?
Path 2 is the specialized, often agentic path. This is for users who've identified a very specific, critical pain point in their workflow that the generalists don't solve perfectly, and they want a dedicated tool to obliterate that pain point.
So if my biggest problem is managing the whole development lifecycle, testing, and reviews,
then you look seriously at something like Quoto, with its multi-agent SDLC coverage and automated PR analysis.
if my absolute priority is data privacy and keeping everything local, even if my machine takes a hit,
then Pieces for Developers with its local LLM execution via Pieces OS is the prime candidate.
and if I just want my VS Code experience to feel like it has superpowers with deep project awareness,
Then you investigate the AI-first IDE forks like Cursor or Windsurf.
it really comes down to identifying your specific need, doesn't it?
Completely. There's no single best tool. It's entirely user-centric and involves trade-offs. You have to ask, are you primarily learning a new language or framework? Maybe Gemini is your best mentor.
Are you working almost exclusively in Python?
PyCharm's specialized AI is probably optimized for you.
Building heavily on AWS infrastructure.
Amazon Q understands those services and respects your IAM roles like no other.
Or is code review, quality, and security the biggest bottlenecks slowing down your entire team?
Then, dedicated review tools like CodeRabbit or CodeMerge might provide the biggest return on investment.
What's really striking, though, looking across all these tools, especially the agentic ones, is the trajectory, the future your sources seem to point towards.
Yeah, it's moving incredibly fast. We're rapidly going beyond simple code completion or even single-task assistance. The clear direction is toward these more autonomous, multi-agent systems.
Where specialized AI agents communicate and collaborate.
Exactly. An agent for code generation talks to an agent for writing tests, which talks to an agent for documentation, which talks to an agent for security review, maybe even an agent for infrastructure setup via tools like Terraform.
The potential there is staggering.
The promise isn't just getting help, it's potentially automating huge portions of the standard development workflow. Imagine setting a task before you leave for the day, and by morning, a significant chunk of the initial code, tests, and reviews are already done, waiting for human oversight and integration.
Which leads us to that final provocative thought for you, the listener, to ponder.
If these AI systems become truly reliable at automating the bulk of the writing, the testing, the linting, the reviewing, all the necessary but often repetitive parts of coding, what will you do with that freed up time and cognitive energy?
If the AI handles the how, what ambitious, creative, complex, maybe world-changing engineering problems will you choose to focus on solving tomorrow?